The urea cycle is a series of reactions used to remove excess nitrogen from the body. This pathway starts with ammonia that is derived from amino acid breakdown and ends with, you guessed it, urea. Now, there's a lot of testable steps and enzymes in this pathway, making the urea cycle a juicy topic for the folks writing your exam. But don't worry, we'll give you an easy way to remember each player so you'll be sure to get the right answer on your exam. Now off to your garage, because that's where this scene takes place. Let's start by taking a look at your unicycle here on the floor. Yep, you own a unicycle because you're really cool. But also because unicycles help you remember the phrase urea cycle, since both start with the letter U and have cycle in their name. And you keep your unicycle in the garage, since no one actually rides unicycles around town. First, focus on the unicycle seat. You recently souped it up with a liver-shaped seat since they're really comfy to sit on. Also, liver-shaped objects are all the rage around Pixarize this year. This liver-shaped seat should help you remember that the reactions of the urea cycle occur inside the liver. This makes sense because the urea cycle is part of amino acid metabolism, and metabolism usually happens in the liver. Now let's take a glance around your garage. Wait, you've left your box of ammo out. Have you been playing around with that airsoft gun again? Anyhow, this ammo reminds me of ammonia, one of the two starting molecules of the urea cycle. Ammo for ammonia? You probably already know that ammonia contains nitrogen, which is derived from the breakdown of amino acids. The main job of the urea cycle is to get rid of this ammonia. Therefore, defects in any part of the urea cycle will lead to a buildup of ammonia, which results in symptoms like lethargy, as well as the classic finding of asterixis, or flapping of the hands when the wrists are extended backwards. By the way, I can tell you've been playing with that airsoft gun, since you also left this carbon dioxide out. You think I can't recognize a gas canister when I see one? In addition to going well with the ammo, these carbon dioxide canisters make me think of carbon dioxide, of course, the other starting molecule of the urea cycle. So you've got air canisters and ammo, which means that there's got to be an airsoft gun somewhere. Oh, there it is. But wait, what have you done? What? You accidentally used your gun on the television? Come on, man, that thing wasn't cheap. And I thought that was your favorite channel, CPS. Let me just say that the CPS logo next to the gun helps me remember CPS-1 or CPS gun. CPS for CPS and gun for 1. Get it? CPS stands for carbamoyl phosphate synthetase, by the way, but you can just remember it as CPS. CPS-1 is the mitochondrial enzyme that uses ammonia and carbon dioxide to form carbamoyl phosphate. For now, just remember this CPS gun for CPS-1. By the way, I always thought your TV was really cool. I mean, it's probably the only battery-powered TV I've ever seen. Just take a look at these two batteries on its side. This also reminds me that CPS-1 uses 2 molecules of ATP, represented here by 2 batteries. Granted, this doesn't feel very high yield, but I just felt like including it for you gunners out there. But let's look back at your garage. You've really made a mess this time. I can't believe the car oil even got punctured by the shards from your screen. Did I ever tell you how car oil reminds me of carbamoyl phosphate? Get it? Car oil for carbamoyl. Your CPS gun really spilled a lot of car oil, which should help you remember that CPS-1 makes carbamoyl phosphate. This is really pretty obvious since CPS stands for carbamoyl phosphate synthetase. Now, before we move on, let's talk about that amateur glue job on your TV stand. You know, I can tell that's a nice stand made of cedar wood. How do I know, you ask? Well, it's obviously because you left that bottle of cedar glue next to it. This cedar glue should help you remember acetyl glutamate, specifically N-acetyl glutamate, sometimes called NAG. N-acetyl glutamate is an activator of the CPS-1 enzyme, which thereby increases the production of carbamoyl phosphate. This is why the cedar glue is helping hold up the CPS TV. You might even say that the cedar glue is activating CPS. Now let's back up and talk about why we're here. You invited me here to clean up your garage, remember? I can't believe you still haven't put away all these holiday decorations. I nearly tripped on that box of ornaments earlier. The word ornament reminds me of the compound ornithine, by the way. Ornithine is the first molecule in the cyclic part of the urea cycle. In other words, the first molecule in the cycle itself. ornithine combines with carbamoyl phosphate to form the next intermediate, which we'll talk about in just a second. For now, just remember our box of ornaments for ornithine, will you? Whoa, is that your ornament train? I can't believe that this is still here. You're probably the kind of person that just puts up holiday decorations once and leaves them up all year. Anyways, this ornament train should make you think of the enzyme ornithine transcarbamylase. Ornament for ornithine and train for transcarbamylase. Ornithine transcarbamylase. Nice. Notice how this ornament train is moving from our box of ornaments into all that spilling car oil. That's a fine analogy for how ornithine transcarbamylase uses both ornithine and carbamoyl phosphate to produce its product, citrulline. Don't worry, we'll talk about those citrulline citrus fruits in a moment, but we're going to take a moment to really hammer in this ornament train. Why? Because the ornithine transcarbamylase enzyme is the most commonly defective step in the entire urea cycle. A defect of ornithine transcarbamylase causes a backup of everything upstream, including carbamoyl phosphate and ammonia. But you can learn more about this in our scene on ornithine transcarbamylase deficiency. Whoa, focus here, buddy. While you were busy explaining the urea cycle, everything went wrong in the garage. Just while you were cleaning, your high school sports banner fell off the wall, taking with it these boxes of citrus from the shelf. Dude, we worked hard picking those citrus fruits from your mom's orchard. Those boxes of citrus have fallen right into the path of our ornament train. This, coincidentally, reminds me of citrulline, the product produced by ornithine transcarbamylase from carbamoyl phosphate and ornithine. Man, have you ever noticed that your garage coincidentally symbolizes a lot of biochemical reactions? Someone must have spent a lot of time arranging these objects. And by the way, why do you still have that sports banner? Go Spartans? It's been a long time since high school, buddy. I don't know about you, but a Spartan always makes me think of aspartate, another key molecule involved in the urea cycle. Aspartate and citrulline combine in the next step of this cycle, which is coincidentally represented by how our Spartan banner has brought these citrus fruits down with it. But why did that banner fall in the first place? Oh, you sucked it up in your vacuum. See that sucker-shaped end? You can really get into the nooks and crannies with it. And I also see that you're wearing your favorite Argentina jersey, because you're an Argentine, of course. At least it's not your old high school Spartans jersey. Anyways, your Argentine self holding that vacuum sucker reminds me of the next intermediate in the urea cycle, argininosuccinate. Get it? Argentine sucker for argininosuccinate? And kind of like how you've sucked down that Spartan banner in citrus, argininosuccinate synthetase uses aspartate and citrulline to produce argininosuccinate. In the vein of battery-powered things, you even own a battery-powered vacuum. Just take a look at that battery on its side. In addition to being super old school, this battery-powered sucker should help you remember that argininosuccinate synthetase uses 1 ATP in its reaction. Not super high yield, but another factoid for you 270 plus folks out there. Now let's take another look at you airsoft shooting, CPS watching Argentine. Yep, your national pride makes this a great symbol for the next step of the urea cycle, arginine. Next, see those fumes your sucker vacuum is making? Turn that thing off, man. It's overheating from trying to suck in that banner. These fumes here are a nice symbol for fumarate, which is also produced at the same time as arginine. In summary, argininosuccinate is broken down into arginine and fumarate. Now, before we move on, I also want to mention the enzyme that catalyzes this reaction, argininosuccinase. Since this is so obvious, we didn't make a symbol for the enzyme. Recall, the ase suffix means to split. So if you just remember argininosuccinate getting split, you'll have the enzyme argininosuccinase in the bag. Now let's go back to arginine. As opposed to fumarate, arginine goes on to the next steps of the cycle, whereas fumarate just floats away, kind of like fumes. Wait, ew, what's that? It looks like your broken vacuum got to you after all. Why do you always pee yourself when stuff goes wrong? Just look at all that urine. This urine should help you remember urea, the final product of the urea cycle. Urea is produced from the breakdown of arginine via the enzyme arginase. And just like before, we didn't make a symbol for the enzyme arginase because, well, it's pretty obvious that arginase splits arginine. But back to the urea. This urea is passed along to blood and later excreted in urine. Hence the urine. As a side note, urea levels in the blood are represented by a patient's BUN lab value, or blood urea nitrogen. You may even see BUN instead of urea on test day, so I just wanted to let you know that they are the same thing. Finally, I want to mention that the arginase reaction also produces ornithine, which is the first intermediate in the cycle. That's right, remember those ornithine ornaments? This is why the urea cycle is a cycle. It just goes round and round, getting rid of urea each time. Before we wrap up, I want to mention one more thing. Lucky for you, knowing the names of the urea cycle's enzymes and intermediates is not enough. Sometimes, examiners will test you on where in the cell these reactions take place. Notice the lighting inside your garage. The light should remind you of mitochondria, since the mitochondria is the powerhouse of the cell. See how it seems to be coming from the top left? While there's a lot of specifics about what's in the mitochondria and what's in the cytosol, you only really need to remember two things. First, your CPS gun is well lit, and second, your ornament train is also in the light. And that's because CPS1 and ornithine transcarbamylase are mitochondrial enzymes. This is high yield, so remember it well. If the lighting doesn't work for you, just think of the light as coming off from the CPS1 screen. Alrighty, that's all we got for this one. Let's recap real quick. The urea cycle is the liver's method to remove excess nitrogen from the body. In the urea cycle, this nitrogen starts in the form of ammonia, which is created by amino acid breakdown. This ammonia then combines with carbon dioxide to form carbamoyl phosphate. This reaction is catalyzed by the CPS1 enzyme, which is inside the mitochondria. Carbamoyl phosphate is then combined with ornithine to form citrulline. Just like CPS1, ornithine transcarbamylase is also found in the mitochondria. Next, citrulline and aspartate are converted into argininosuccinate, and this reaction occurs via the argininosuccinate synthetase enzyme. Next, argininosuccinate is then broken down by argininosuccinase to form arginine and fumarate. Lastly, arginase splits arginine into urea and ornithine. The urea is excreted inside the urine, thereby getting rid of nitrogen, whereas the ornithine goes right back into the cycle. And so, the cycle goes round and round. In short, the urea cycle is really all about excreting nitrogen as urea. Everything else is really just a supporting player to help the body get rid of this nitrogen. And if you only remember one thing about the urea cycle, that's what I want you to remember. Now, I think I'll take your unicycle for a spin. On to the next scene.